Hi, Assalamu alaikum. How are you all? I think all of you are well by the grace of Allah. Today I have come in front of you taking another video and it is about chemical reaction. It is chapter number 7 from the book of class 9 and 10, and it is very important topic for SSC examination 2026, and it is critical question number 3, exercise 3 of your own textbook. You're noticing that a stimuli, sodium plus 1 molecules of sodium, 1 mole sodium plus half mole chlorine gas produces sodium chloride, 1 molecule or 1 mole sodium chloride salt. Now you are noticing another reaction, zinc plus sulfuric acid, then it is producing zinc sulfate, salt and hydrogen gas. Now the first question was what is called isomerization reaction. It was the question, what is called isomerization reaction? So let's define it. In which reaction the common formula or the compound's chemical formula is same, but the structural formula is totally different? It can be called as isomerization reaction. Okay, now I'm repeating it. In which reaction the compound chemical formula is same, but the structural formula is totally different, then it can be called as isomerization reaction. The answer of the first question has been completed. Okay, now I'm going to second one. Second one was, what do you mean by reversible reaction? This was the question. What do you mean by reversible reaction? Yes, it is also a very simple and very normal question for you. If you know the basic concept of this chemical definition, then you can define it very easily, and it is not a very hard and complex topic for you to just define. Okay, what do you mean by reversible reaction? You know, based on the direction of a chemical formula, it can be classified into two categories. Number 1, reversible. Number 2, irreversible. Now I have to define reversible reaction. Okay, let's get started. Reversible reaction. What do you mean by reversible reaction? In which reaction reactants can be turned into products? I'm saying it again. In which reaction reactants can be turned into products? At the same way, products can be turned into reactants. At the same way, product can be turned into reactants, then it is called reversible reaction. So we can exemplify it. 1 mole of nitrogen gas, 3 moles of hydrogen gas produces 2 moles of ammonia. And here 1 mole nitrogen gas and 3 mole hydrogen gas produces 2 moles of ammonia. At the same way, 2 moles of ammonia decomposed into sodium gas and hydrogen gas. 1 mole sodium gas and 2 moles of hydrogen, 3 moles of hydrogen gas. So the first direction and the second directions run at the same way simultaneously, then it can be called as reversible reaction. Understand? Now the next question was, see, in the second reaction determine the oxidation number of the product. This was the question. In the second reaction, determine the oxidation number of the product. We know the determination rules of oxidation number, so I'm not going to just illustrate those formula. I will just directly solve and sort out it. I think that all of you will understand it better. Now we'll have to just complete the equation. Okay, zinc plus sulfuric acid, then it produces zinc sulfate plus hydrogen gas. You can see in the second, in the production range, in product, sulfur has the presence in zinc sulfate, and there is no other compound in production or yields. Hydrogen is single, so here there is no presence of hydrogen. That is why we can take only zinc sulfate, and we'll have to define the oxidation number from this product. Okay, because sulfur has the presence only in zinc sulfate in production side. Okay, so get started. Zinc sulfate is our compound. We'll have to define or determine the oxidation number of this sulfur. Okay, just write down all others oxidation number, then it will be very easy for you to just determine the oxidation number of sulfur. We know the oxidation number of sulfur is 246. We don't know in this compound what will be the value of oxidation number, so we'll have to define others oxidation number. So we know the oxidation number of zinc is +2, so just place +2 into its atom. There is no number in the right side of zinc, so we can obviously take it as 1 plus. We don't know the exact number of oxidation number of sulfur, so we'll have to determine it. So we will let it or suppose it x. It is x into the atom will be 1. There is no number in the right side of sulfur. Now plus again. We know the oxidation number of oxygen is -2 into the atomic number is 4. The atom number is 4, so we will write 4, and the whole compound is basically neutral. That is why we will place equal to 0 as equation to produce or to make equation. Now just write down 2 multiplied by 1 means 2 plus x multiplied by 1 means x plus minus. If you multiply, then you will get minus 2 multiplied by 4 means 8 equal to 0. Then if you subtract 2 from -8, then you will get x minus 6 equal to 0. Then x equal to 6. Then the oxidation number of sulfur is +6. This is the answer of this question. I think that you have understood it. Now we are going to the next question. You're noticing that in the question number D, in the first reaction, redox caused simultaneously. Just analyze it. This is the question. In the first reaction, redox caused simultaneously. You will have to just analyze it. Okay. We know in which reaction electron can be just shared, or electron can be just give and take. Then we can determine it as reduction and oxidation reaction. So from this purpose, we can write the whole reaction. Sodium plus chlorine gas, half moles of chlorine gas, then it is producing sodium chloride. Okay. Now we'll have to just define the oxidation number. We know a free element has the oxidation number not 0, and chlorine has also not 0, but sodium has +1, chlorine has -1. Okay. Now we'll have to define which one is reduction and which one is oxidation. You know, if plus increases and minus decreases, then it is oxidation, and the element will be the element will be reductant. If minus increases and plus decreases, then it is reduction. The element will be oxidant. This is the formula to perform in redox reaction, reduction-oxidation reaction. So you are noticing that sodium has not, zero charge, but here you are noticing sodium has plus charge. Plus has been increased or plus increases. That is why we can give a mark this sodium to that sodium, then plus increases. That is why we can write oxidation. So sodium is, we can write oxidation, half reaction. Now we are just marking off chlorine, this chlorine to that chlorine, then we can write reduction. It is reduction. Here sodium is just emitting electron and chlorine is just receiving electron. So as sodium is emitting electron, that is why we can say sodium is reductant, and chlorine is receiving electron, then we can obviously say chlorine is oxidant. But the process of emitting electron is called oxidation. The process of receiving electron is called reduction. Understand? So we will just say oxidation or reduction half reaction now. Okay, let me write. Sodium has 0, but after the reaction it emits 1 electron. But chlorine has 0. Chlorine received that electron, then chlorine turns into -1. It is oxidation half reaction, you can write, and it is reduction half reaction. Here sodium emits and chlorine receives, so the electron will be given and taken. That is why it is same. So sodium not plus chlorine not, it is now resting, and the next one is sodium plus chlorine minus, then it is similar to sodium chloride. It is reduction whole reaction or entire reaction, you can write. It is the happenings that I have to prove this reaction. So if you write down only these points, then you will not get full marks, because I am not writing down the whole description that which elements is emitting and which element is receiving. I'm not writing down this, so you will have to just define it. I have just spoken it through my writing down. That is why if you can write all the description explanation, then you will get full marks. Okay, I think that you have understood it. You have understood it in a better manner. And thank you for staying with me. Goodbye, everyone.